Okay, good day. So today we are to proceed on another operation for matrices. So we have the multiplication of a scalar quantity and a matrix. So for example, we have C, a scalar quantity, and let's say A will be our matrix. So if you are looking for the product of the scalar quantity C and matrix A, this is the same as C multiplied to all elements of the matrix A. So let's say elements 1, 1, A1, 2, up to let's say A1n. Let's say this is A21, A22, up to A2 sub n. Then for example, on the last row, this is A sub m1, A sub m2, up to the last element, A sub m(n). So all we have to do is multiply this scalar quantity to all elements of matrix A. So let's have an example. For example, we have a scalar quantity C equal to 3 and matrix A with the elements 1, 0, negative 3, 2, 1, 4, 6, negative 4, and 5. For example, we are looking for the product of the scalar quantity C and matrix A. This is equal to the scalar quantity 3 multiplied to all elements of matrix A. So elements 1, 0, negative 3, 2, 1, 4. This is 6 and negative 4, 5. So all we have to do is multiply 3 to all elements. So we have the product. This is 3 times 1. We have 3, 0. 3 times negative 3 is negative 9. 3 times 2 is this is 6. Positive 3. 3 times 4 is 12. 3 multiplied by 6 is 18. 3 multiplied by negative 4 is negative 12. And 3 multiplied by positive 5 is positive 15. So this is the equivalent of the product of the scalar quantity C and matrix A. So this will be our answer. So let's have another example. So for example, we have this time a scalar quantity C is equal to 2. Matrix A with the elements 2, 0, 3, 6. Matrix B with the elements 4, negative 5, 3, and 1. We are looking for the equivalent of matrix C multiplied by the quantity matrix A plus matrix B. Or it's the same as scalar quantity C multiplied by the quantity matrix A plus matrix B. If we are to apply distributive property, scalar quantity C multiplied by the quantity matrix A plus matrix B is the same as C multiplied by A plus C multiplied by matrix B. So we may choose or we may use any of this two. So for example, we are to use the first one. This is C multiplied by A plus B. Is equal to our scalar quantity is 2. We are just to add the elements of matrix A and matrix B. So that's the same as we have 2 plus 4. Then we have this is 0 plus negative 5. That is 3 plus 3. Then we have 6 plus 1. We simplify. This is now equal to 2 multiplied by, we have this is now 6, this is negative 5, this is positive 6 and positive 7. Then we multiply the scalar quantity to all elements of the resulting matrix. So this is the same as 2 times 6 is 12, 2 times negative 5 is negative 10, this is positive 12 and positive 14. So this will be the equivalent of C multiplied by the quantity matrix A plus matrix B. Using this set. What about again, if you have to apply distributive property, let's try this one. Just to prove that they are equal, so we have C multiplied by matrix A plus C multiplied by matrix B. We have the scalar quantity 2 multiplied by the matrix A. This is 2, 0, 3, 6. Then plus, we have, this is 2 multiplied by matrix B. We have 4, negative 5, 3, and positive 1. So we multiply the scalar quantity to all elements of each matrix. So we have, this is now equal to, we have 4, 0. This is 6, 12 plus 2 times 4. This is 8, negative 10. 2 times 3 is 6. 2 times 1 is this is 2. So we are now to add the corresponding elements from the two matrices. We have what is 4 plus 8. This is now 12. 0 plus negative 10 is negative 10. 6 plus 6, that is 12. 12 plus 2, this is the same as 14. So this is the same as C multiplied by matrix A plus C multiplied by matrix B. So do we arrive with the same answer? Yes. So this will be our answer. Okay, we proceed to multiplication of matrices. So for example, we have matrix A, and the dimension of matrix A is m by n, and matrix B with the dimension, let's say Q, number of rows, by B, a number of columns of matrix B. It is only possible to multiply matrix A and matrix B if they are conformable. So conformable for a reason, let's say n is equal to Q. The number of columns of matrix A is equal to the number of rows of matrix B. Okay, for them to be conformable. So we have the dimension of matrix A multiplied by matrix B. Dimension of matrix A is m by n. The dimension of matrix B is Q by P. So again, first condition, the number of columns of matrix A should be equal to the number of rows of matrix B, and the resulting matrix will be, the resulting dimension of the product matrix is m by, this is m by P. So let's have an example. As a result, we have matrix A with the elements 1 to 4, matrix B 1, 2, 0, 3, 4, and 1. What is the dimension of matrix A? Matrix A, let's say this is m by n. The dimension is 1 row, then 3 columns. Alright, this row matrix. Matrix B, let's say this is Q by P. The dimension of matrix B is we have 3 rows by 2 columns. Matrix A with the dimension 1 by 3. Matrix B with the dimension, what's the dimension of our size of matrix B? This is 3 by 2. So we can conclude that they are conformable since we have the number of rows, number of columns of matrix A is equal to the number of rows of matrix B equal to, equal to 3. So the resulting matrix should be m by P. So this is m by P, or that is the same as 1 by 2. We are expecting a resulting matrix with a size of 1 by 2. So basically all we have to do is multiply the row of matrix A to the columns of matrix B. So let us compute or solve for matrix A multiplied by matrix B. This is equal to, again, we are expecting a 1 by 2 matrix. So, multiplying the first row to the first column with their corresponding elements. So, we have, this is the same as 1 by 1, okay, 1 multiplied by 1. Then we have plus, this is 2 multiplied by 0. Then plus 4 multiplied by 4. So this is 4 multiplied by 4. So the sum of these terms will be the first element. Then, okay, again, we have to multiply the row of matrix A to the second column of matrix B. So take note, we are just multiplying a row to a column. So we have that as, okay, the row of matrix A, we have 1, I multiplied by, we have 2, multiplied by 2, plus, this is 2 multiplied by 3, this is 2 multiplied by 3, and 4 multiplied by 1. So this is 4 multiplied by 1. Then we have to simplify. This is now the product of matrix A and matrix B equal to, so 1 times 1 plus 0 plus 16. This is 17. Then we have, this is 1 plus 1 times 2 is 2 plus 6 is 8. 8 plus 4, this is 12. This is 12. So 2 plus 6 is 8 plus 4 is 12. So this is the product of matrix A and matrix B. And so let's have another example. For example, we have matrix A, which is, what is the dimension of matrix A? This is m by n. So this is, we have 3 rows and 2 columns. For matrix B, we have, this is Q by P. We have 2 rows by 3 columns. So if we are to compute for the product of matrix A and matrix B, so let us check if they are conformable. So basically we have the number of columns of matrix A, we have 2 columns. The number of rows of matrix B is also, equal to 2. So they are conformable. So we have the dimension of matrix A, that is 3 by 2. The dimension of matrix B, this is 2 by 3. So therefore, we are expecting a resulting matrix with a dimension 3 by 3. So 3 by 2 matrix. So let us solve. So this is A times B. We are expecting a 3 by 3 matrix. So all we have to do is multiply the rows of matrix A to the columns of matrix B. So let's have the first element, that will be the first row to the columns of matrix B. So the first row of matrix A to the column of matrix B. So we have, that is the same as 2 times 1 plus 0 multiplied by, this is 0 multiplied by 3. That is the first element of the first row. We proceed to the second element of the first row of A times B. That is the first row of matrix A. This time we proceed now to the second column of matrix B. So that is 2 times 0 plus 0 times 4. Alright? Then, we have the first row of matrix A to the last column of matrix B. So we have 2 multiplied by 2 plus, this is 0 times 1. So that will be the first row of the product of matrix A and matrix B. All we have to do is repeat the process. This time, we proceed to the second row of matrix B. We have, there is 1 multiplied by 1 plus, we have 4 multiplied by 3. That is, next we have 1 multiplied by, the second column of matrix B this time, 1 times 0 plus 4 by, this is 4 times 4. Then, second row to the third column, that is 1 multiplied by 2, 1 multiplied by 2, then 4 multiplied by 1. So we have 4 multiplied by 1. So that is for the second row of the resulting matrix. Now we proceed to the last row of matrix A. The last row of matrix A to the columns of matrix B. So we have 3 multiplied by 1 plus 1 multiplied by 3. Then we have third row of matrix matrix A, second column of matrix B. That is the same as 3 times 0, 3 times 0 plus 4 multiplied by, we have that as 1. This is 1 multiplied by 4. Okay, on the third row to the third column. So this is 3 multiplied by 2 plus 1 multiplied by 1. So as you can see, the resulting matrix is a 3 by 3 matrix. So we simplify. This is A times B equal to, so we have 2 times 1 plus 0 times 3. This is 2. 2 times 0 plus 0 times 4 is 0. 2 times 2 plus 0 times 1, that is, okay, we have 4. 1 by 1 plus 4 by 3. This is 13. 4 times 3, 12 plus 1, that is 13. 0, 16. This is 2, 4. This is 6. 3 times 1 plus 1 times 3. This is also 6. 3 times 0, 1 times 4. This is 4. 3 times 2 is 6 plus 1. We have 7. And this is the product of matrix A and matrix B, which is this time a 3 by 3 matrix. So this will be our answer.